just trying to be like Dr. Winsberg. Um, yeah, so both of these are correct. Why? Because just the definition of Ka, it's for acid, and it's always with the acid on the left. And there's two ways to write these acid equations. You know, we can either do it with water or we can just kind of ignore water and do it with H plus. But yeah. Any questions about this? So if you needed a K value for this equation or that equation, what would it be? 1 over Ka. Yeah. Is that the same thing as Kb? No. Okay. Because Kb is for bases. Yes. Thank you. That was a good answer. Yeah, Kb is for the base plus water. So we're going to do this problem now too. You only have two options, so 50-50, right? And if this doesn't make sense, when we do the titration problems, we're going to kind of see how we move these around. And I think we're about to get to titration. I think we're about at that point. Okay, how many people say A? You're wrong. No. How many people say B? Okay, A is the right answer. There you go. So Kb is always for a base plus water. Yeah, I guess that's a really good way to think about it. Kb is for a base plus water. Ka is for an acid plus water. But sometimes for acids you just don't write water. But yeah, there we go. So important equations. Kh and Kb, Kw, all these things. This is really important. It's conjugate acid-base pair. So can you take Ka and a Kb of any two things and combine them together to get Kw? No. It has to be for a conjugate acid-base pair. Does everyone understand what a conjugate acid-base pair is? Okay, good. Good. We'll keep going. Okay, let's just kind of review for a second. Here's some more important acid-base principles. Strong acids and strong bases. Everybody say it out loud. Completely dissociate. Soluble salts completely dissociate. This is something that's important to remember too. Does anyone remember from Chem 105 what our soluble salts are? No. Does anyone remember anything from Chem 105? No, that's okay. So we've got salts. So the soluble salts are group 1 salts, and then ammonium salts, and nitrate salts. So if it has Na or K or what are the other group 1? Li. If it has any of these in it, then it's going to be a soluble salt. What do soluble salts do? They completely dissolve. Why does this care and why do you care and how does it relate to acids and bases? It's because lots of times you get a problem like this, where you add KCH3COO to water. What happens? It dissociates, right? Then what's CH3COO minus? So this splits up and we get K plus and CH3COO minus. What is this? Base. Yeah, conjugate base. So if you put this in water and there's nothing else, what is this going to do? It's going to react with water. This is a base, so is the pH going to go up or down? Up. Okay, and we're going to talk about in a second why the K plus doesn't matter. But soluble salts, stronger acid has a weaker conjugate base, weaker acid has a stronger conjugate base. If you have anything strong, the reaction will go to completion. Does everybody feel okay with this? Yeah.
Sorry, with the same one.
Yeah.
Is that the conjugate base then of that, or conjugate
So, if you have a strong base, okay, let's do this. So, what is this? Strong base, strong acid. What do bases do? Bases want protons, acids give protons. So you've got something that really wants a proton and something that really wants to give a proton, so they react completely. And that's also true though, like if you have a strong base and weak acid. So again, what do strong bases do? Strong bases are proton acceptors. Strong bases really want protons. Then a weak acid is something, it's an acid, right? And so it's a weak acid, but it's an acid. So it's willing, it's kind of willing to give up a proton. So if you've got something that's willing to give up a proton and something that really wants to take it, then they just react. Does that make sense? So that's why. So these are just important principles to remember. And, okay, this is really important too. It's all really important. But, let's see. Do you want to talk about these rules first and then do titrations, or do you just want to do titrations now? Or do you want to talk about these rules? Okay, let's talk about these rules. Okay, so yes, the rest of it's important, and so is this. You need to remember these rules. And hopefully, like, I don't know, you can think about it and it makes sense. The way I remember it is just to go through your 4 options: strong acid, strong base, weak base, and just kind of think about what they do. So the conjugate base of a strong acid has no effect. So if we go back, so all of these things, right? What's the conjugate base of HCl? Cl minus. What's the conjugate base of Br minus? Or of HBr? Minus. Good job. And so these are the strongest acids possible, right? So if it's a really strong acid, the conjugate base is really, really weak, right? And so these are the conjugate bases are the weakest possible bases. And they're so weak, in fact, that they don't have any effect on the pH. They don't do anything. Does that make sense to everybody? Any questions about that? That's why this rule is true if we come back. So that's why the conjugate base of a strong acid has no effect. Conjugate base of a weak acid. So what's an example of a weak acid? Acetic acid. What's the conjugate base of acetic acid? This. Yeah, there it is, right there for you. And it raises the pH, which is what we just talked about. Does everyone understand why that would raise the pH? Yeah. So it's conjugate base. So let's go back to our table here. Where's acetic acid? Here's acetic acid. So weak acids have slightly stronger conjugate bases, right? And so the conjugate base of acetic acid, it's still a weak base, but it's a lot stronger than like Cl minus, right? And so for that reason, it can act as a base and pull the proton off water and increase the OH minus and raise the pH. Does that make sense to everybody? Any questions about that? And so we have the conjugate base of a weak acid will raise the pH. So the cation of a strong base has no effect. So strong base, for example, KOH. So the cation, this part of the strong base, that's not going to affect the pH at all. Which is why, again, in these problems, lots of times he'll give you like a salt like this. And he'll say, you add potassium acetate to the solution. You know that it's a salt, you know that it splits up, you know that this is a weak base and it affects the floating around, and people are like, where does that go in my equation? Where does that go in my equation? That's where knowing these rules is helpful, because if you ever have Cl minus in an acid-base problem, then just erase it, get rid of it. It doesn't matter because it doesn't affect the pH. Does that make sense? Okay.
But if you were to figure out the Ka of that equation, you'd still include the concentration of potassium, right?
Okay, well that's another good question. So would this equation have a Ka? No. What is this?
Oh,
Salt. So actually, what K value would be right for this?
KSP.
It would be KSP. And in the problems you have in your homework, the KSP is always really, really small. But what would be the KSP of this equation? It would be huge. KSP would be a lot bigger than 1 because it completely dissociates. Yeah, does that answer your question?
Yeah, it does, yeah.
Okay. Good. Yeah.
And so KSP, you wouldn't include the reactant at all, right? That's because it's salt.
Yeah, you wouldn't even include this because it's a solid. Yeah.
So it'd just be the K times the.
Yep, it would just be K times that. Yeah. Yes.
So if in like one of these problems we were left on the right side with one of the very weak bases, would they have any effect on the pH?
Like Cl minus or Br
Yeah.
minus. No. No effect on the pH. Because they're such weak bases that they don't affect it.
But so anything in the middle is good?
Anything in the middle can affect it. Yeah. And so that's why the conjugate acid of a weak base, so our classic weak base is ammonia, right? NH3. Conjugate acid is NH4 plus. That's gonna lower the pH. Does everyone understand why that would lower the pH? Okay. Yeah. Did you have a question, Matthew?
Yeah, I was just wondering, if we don't include potassium there, why are we including it in KSP in the equation?
Oh, okay. Don't worry about this. Because this is all, I mean, that was just, this is, we include it in the KSP because, I mean, KSP is for salts and we just do reactants, or products over reactants. The reactant is a solid, so it doesn't exactly work.
Okay, so there's different rules then for salts to be able to include that potassium.
Yeah, but KSP is different because right now, what we're really talking about is Ka, and the point that we want to make here is just that K plus, that's the cation of a strong base, so it's not going to affect the pH of the solution. Does that make sense? Okay. Other metal ions lower the pH. So other metal ions, so any of the things that aren't cations in strong bases, like Mg2 plus or Fe2 plus, lowers the pH. And the way that I think about that is that, like, if you have iron, like, well, the things usually like to be really positively charged or really negatively charged, or do they usually kind of like to just be neutral? Yeah, right? So Fe2 plus has got all this positive charge, so if it comes into contact with water, this is just the way that I remember it, but it's almost like it can pull off the OH minus. And so that would leave you with this, right? Fe2 plus and OH minus. So then what's the net charge here? It's now just plus 1, right? So iron is more happy because it's kind of more neutral, but that leaves you with H plus, right? So if you have all this extra H plus floating around, then that lowers the pH. So maybe that helps you remember that, but that's the way that I think about it. Any questions about these principles? Yeah.
You described, you talked about Arrhenius bases, or strong Arrhenius acid and strong Arrhenius bases.
Yeah.
How does that come into this? Do you do that matter?
What did he say exactly?
I don't remember, but I remember when you listed off this, there was 5 or 6 rules that like strong Arrhenius bases do this, and strong Arrhenius.
Yeah.
But I think those are just like they're the salts.
Yeah.
You know, group 1 salts. I don't know.
I mean, go back to his slides, but I don't remember there being anything special about like Arrhenius acid. Okay. So knowing these rules is going to help us. Okay, yeah, answer these questions. If you stick the following salts in water at pH 7, what would be the effect? Okay. NH4Cl. Everybody all together? Lower pH. FeCl3. Everybody all together? Lower pH. What about this one? Raise pH. Lower. Sorry, we went through that kind of fast because I want to get the filtration. Yeah. But it just so NaCl, Cl minus. What's Na plus? Cation with a strong base. What's Cl minus? Conjugate base with a strong acid. So neither of those has an effect. The pH stays the same. So that's the way that you can think about this problem. So just look at each piece and see if it has an effect based off of those rules. Anyone have any questions about this? Do you want me to go over this more? Yeah.
Just what's the difference between NaCl and NH4Cl?
Good question. So, well, NH4Cl is going to be NH4 plus and Cl minus, right? So what's Cl minus? Conjugate base with strong acid, no effect on pH. What's NH4 plus? Conjugate acid with a weak base. So conjugate acid, no it's on the pH goes down. Does that make sense? Any other questions? Okay. Buffers, we've got buffers. Okay. Okay. If anyone, I think the next thing we want to talk about is titrations. Is that okay with everybody? Yeah. Does anybody have anything else they have questions about before we start talking about titrations? Yeah. Oh yeah, that's a good question. Okay. So what is a buffer? A buffer is just a mixture of a weak acid and its conjugate base, or a weak base and its conjugate acid. Buffers hold a pH constant. We use the Henderson-Hasselbalch equation. And this last one, do you guys remember learning this in class? The best buffers. So the best buffers will have an equal concentration of acid and conjugate base, and they have higher concentrations. So I'm sure that would be one of the test questions too. But like if you had 0.1 molar NH3 and 0.1 molar NH4 plus, or 5 molar NH3 and 5 molar NH4 plus, which one is the better buffer? The 5 molar, because we've got higher concentrations, right? What if you've got 0.8 molar NH3 and 0.8 molar, or actually 1.2 molar NH4 plus? Of these two, which one